Hi, this is online Matlab tutorial, a lecture for the course E556 Digital Signal Processing. In this lecture, you will be introduced to Matlab software, and I'm going to be talking about how to use Matlab and how to run programs on Matlab. So as you can see on the screen, Matlab has several windows. The main window is a command window where you can type your commands and run your programs. This window shows the current directory, and the current directory is where you put the files that you want to run on MATLAB. And the current directory can be changed. It is shown here, and it can be changed by browsing your hard drive or flash drive or wherever you have stored your MATLAB files. This window here is the workspace, and it shows the variables that you have executed so far, or the commands that you have executed, and the variables that are stored in the memory of your computer, or basically MATLAB. Right now it's empty because I haven't stored anything in the memory of MATLAB, and I'm going to show you later that whenever you introduce a variable, that variable will show up here in this workspace window. The other window is the command history. So if you type a command or execute a command here in the command window, it'll be stored here, and you can actually recall that command and execute it again later. For example, if you can see here, today I executed these commands, and if I don't remember what I executed yesterday or days before, I can just go back and find the command that I used several days ago. So basically this is the environment of MATLAB, and I'm going to show you how to use the other commands and the other windows later. But the fact is that you don't need to know everything about MATLAB to be able to use it. That's the beauty of this software, and the software has a lot of resources and a lot of commands that you can use. What you need in this course probably is a very teeny tiny portion of the resources and tools that you have and are available with MATLAB. So I'm going to start with a simple procedure like introducing a variable. Now, when you want to define a variable in MATLAB, you have to choose a name for that. Now, the name can start with a letter. That could be capital or lowercase, it doesn't matter. But MATLAB is case-sensitive software. It means that if you use little x, you have to distinguish it with a big X. So let me introduce a variable. I'm going to call it x, and I assign a number to that, for example 1. Now when you hit the enter, that variable will be stored in the memory of MATLAB. And you can see here in the workspace window, you can see x, and this sign is a matrix. So basically x is a matrix, and because here we have only one number, it's a 1 by 1 matrix. And by the way, MATLAB is actually the abbreviation of Matrix Laboratory. So basically whatever we have in MATLAB is a matrix. Now, as you can see, after hitting the enter, you will see the replica here that shows x is equal to 1. Now if I generate or introduce a new variable, big X, that would be different from the previous variable, which was little x. So as you can see, we have big X and little x, and these two are different. So please remember, MATLAB is case sensitive. Now, using the same method, we can introduce matrices. So before talking about matrices, let me explain how you can introduce vectors. So, for example, I'm going to introduce little a equals to a vector like this: 1, 3, 4, 5. And when I hit the enter, a will be stored in the memory of MATLAB as a vector. So if you don't want to see the replica of or echo actually of the vector here, you can let me introduce another vector like b equals to 4, 7, 9, 10. You can put a semicolon at the end of the line, and then when you hit the enter, the command will be executed, but it will not be shown on the command window. And this is useful especially when you are writing a program. When you are writing a program, you may have hundreds of lines. Now, while you are running the program, if you don't put the semicolon at the end of each line, then MATLAB is going to show the result of the execution of that line while the program is being executed. And you will see a lot of garbage here on the command window, and it's going to actually slow down the execution of your program. So whenever you don't want to see the result of the execution of a line, you have to put a semicolon at the end of that line. Okay, so now we have created 4 variables. A and B are vectors. So if you want to see the content of a vector, you can just type the name of the vector and hit the enter. Then you can see the content of that vector, or for example B. Now, there is a very useful command when you have a lot of things here on the command window and you want to actually erase them. You can type CLC, which is clear screen, and then you can clear everything on the command window. CLC doesn't erase the variables in the memory, so it just clears the screen. Now if you want to get rid of the variables in the memory or in the workspace, you can use clear. So for example, I'm gonna delete big X, so I'm typing clear big X, and as you can see in the command window, when I hit the enter, big X will disappear. So if you want to clear all variables, you can type clear all. Okay. Now if you have questions about a particular command, or if you want to see how you can use a particular command, you can simply type help and the name of that command. For example, in this case, clear, and it shows various things that you can do with that command here. Now if you want more comprehensive help, you can use doc clear instead of help clear. So if you do that, you're going to get yeah, if you hold on a second while it's being loaded. Now I can bring it into the visible portion of the screen. Okay. Now we can see the comprehensive help that you can get. This is clear, and descriptions and all variables and other things related to that command, and you can get some examples. If you don't know what to do with that command, or you need some examples, this help will provide you with everything. So you can use this on any command. So let's go back to our discussion. So let me erase everything here. As you can see in the command history, all the commands that have been executed are here. So if you want to re-execute some of them, you can just double click on that and it'll be executed. So now we have a vector here, and it has 3 entries. Let's define a matrix. So in order to define a matrix, you have to enter rows one by one. So I'm gonna create a 3 by 3 matrix. So the first row is 1, 2, 3. Then you can separate the rows by typing a semicolon. So the second row will be 4, 5, 6, for example, and the third row will be 7, 8, 9. And then you can finish the line by a bracket and hit the enter, and you will see that Z will be introduced as a matrix, a 3 by 3 matrix. Now, the next thing that we should know about generating matrices is other operations that we can do. For example, let's consider A, which is a 1 by 3 matrix, or a vector, or a row vector basically. We can transpose this vector by using this command. So if we use dot apostrophe, then we can create a column vector. Now let me, and by the way, if you use up arrow and down arrow keys, you can actually get back to the previous commands, or you can directly go to the command history. So actually up arrow and down arrow go over the lines that you have on the command history. So let me do this again, and let me assign it to another variable like y. So y here will be a column vector, as opposed to a that was a row vector. Now the next topic will be using the colon operator. Let me clear the screen here. Now I'm going to create a row vector whose entries are set as equidistance numbers. For example, let's create this row vector first manually. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, instead of typing everything, you can define this by using a colon operator. So type the first entry, which is 1 here, colon, and type the last entry, which is 10. So it's going to be 1 through 10, and Z1 would be 1 through 10. Now, suppose that you want to define this vector. 1, 4, 7, 10, 13, 16, 19. Now, one way is to manually enter every single entry, which is not a good idea if the length of your vector is big. The other way is using the colon operator. So you can start 1. Now as you can see, the step size of this sequence is 3. So type the step size, and finally the last value, which is 19. So this is how you can create equidistant sequences or vectors. Now the step size could be negative. For example, z2 is, let's consider 20 minus 4, and that will be 0. So in this case, as you can see, it's a descending sequence, and the step size is minus 4. So obviously in this case, the starting point should be greater than the ending point. Otherwise, you're not going to get anything. So for example, if you do this, you're going to get an empty matrix, which is kind of obvious, because you can't add, actually subtract from 0 and get to 20. So that's kind of obvious. So this is how we generate ascending or descending sequences. Alright, the next thing is how to access different entries of a matrix. So that would be our next topic. Okay, to access the entries of a matrix, we have to use the column number and the row number of those entries. For example, here we have a matrix. Let me define a matrix like y equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, in order to access the first entry, 1, we can use the row number and the column number of that entry, which is 1 and 1. So y of 1 and 1 is 1. To access this number, 8, we can type, as you can see, this entry is at row number 3 and column number 2. So we can access to that entry by typing y of 3 and 2. Now sometimes we need to access a submatrix. For example, let's access 5, 6, 8, and 9. So that will be here between row number 2 and 3 and column number 2 and 3. So it will be y of 2 through 3 and 2 through 3, 2. Now sometimes we need to access a column, like the second column, for example. So in that case, because we are accessing only one column, row numbers are not important. So in this case, we have to substitute the row number with column, which means we are accessing all rows but at the second column. Now we can use the same thing to access one row. So in this case we will have, for example, the third row and all columns. Now sometimes we can access the submatrices that whose entries are not next to each other. For example, we're going to access 1, 3, 7, 9, the entries at the corners of a matrix. So we can choose bracket here. So we're talking about first row and the third row, and also first column and third column. So you can use this method to access the other submatrices like 2, 3, 1, 3. That'll give you 4, 2 by 1, and 6, 2 by 3, and 7, which is 3 by 1, and 9, which is 3 by 3. So with this method you can access different entries of a matrix. Now I'm going to talk about basic operations. Now if you want to, for example, add two numbers, you can just use the addition or subtraction or multiplication like these, and they're pretty much like the operators that you use in your calculators. Now if you want to use these operators on matrices, we have two different forms. Let me talk about addition of two matrices. Now we have, for example, let me create two vectors like 1, 2, 3 as A1 and 7, 8, 9 as B1. Now obviously we can add these two vectors, and let me put the result in C1. So that's going to be the sum of two vectors, and as it is obvious, the size of the vectors should be the same, otherwise we won't be able to add them up. So for example, let me define a vector with 4 entries, and if you try to add A1 and Z1, you're going to get error, obviously. So this is for addition. For subtraction we have the same scenario, but for multiplication it's different. Okay, let me create two matrices. M1 is a 3 by 2 matrix like this, and M2 is a 2 by 5 matrix, for example. So we're gonna have this matrix. Now obviously we can multiply M1 and M2 because the number of columns in M1 is equal to the number of rows in M2, and we get obviously a 3 by 5 matrix. But we cannot multiply M2 by M1 and we get an error, obviously because the number of columns in M2 is not equal to the number of rows in M1. So you have to remember that multiplication is actually matrix multiplication in Matlab. So the order of multiplying two matrices is very important. Now we have a different set of operations in Matlab, and those operations are valid for entry-wise operation. For example, if you want to have uh, an entry-wise multiplication or entry-wise division or entry-wise power, um, you can use those operations. But before talking about that, I should mention the power. So when you want to raise a number to the power of another number, obviously you use an up arrow like this. Now you can use this operation for matrices, but raising a matrix to an integer means multiplying that matrix by itself several times. Now you can do that only for square matrices. For example, let me define M as a 2 by 2 matrix. Now you can raise M to the power of an integer. Let's find M squared, for example. Means M times M. Now M cubed means M times M times M, and so forth. So and this is only valid for square matrices, where the number of columns and the number of rows are equal. Now, let's get back to the entry-wise operation. In some cases, especially in DSP, we use these operations a lot. You have to multiply the matrices or vectors element by element. For example, suppose that we have two vectors like this. C1 is equal to 1, 4, 5, 7, 9. And C2 is equal to 7, 0, 8, minus 6, and 3. Now we would like to multiply 1 by 7, 4 by 0, 5 by 8, 7 by minus 5, and 9 by 3. So in this case, we can use this operator, dot star. So whenever you add a dot before any kind of operator, you actually turn it into an entry-wise operation, or element by element operation. So in this case, C1 dot star C2 will be this vector, which is obviously the product of the entries of these two matrices. So this operation is very important, and it's very useful in signal processing. There are some other commands related to matrices that I would like to mention some of them, which are very useful. For example, if you want to find the size of your matrix, the number of rows and number of columns in that matrix, you can use the command size. So for example, let me choose size of M1. Now M1 has already been created, and you can see that it exists in the workspace. So size of M1 would be 3 and 2. Now if you want to capture these numbers, you have to create a variable for each of them. For example, number of rows and number of columns, and you get R equals to 3 and C equals to 2. Now if you have a vector, a vector means a matrix whose either number of columns or number of rows is equal to 1. We had created 2, C1 for example. In this case, we don't need to have the dimensions of the matrix, because one dimension is always equal to 1. So in that case, we need only the length of the matrix. So we can use this command, which gives us the length of C1. Another useful command is zeros. With this command, you can generate a matrix whose entries are all equal to 0. So for example, I'm going to create P. with 3 rows and 5 columns, and this command gives me a 3 by 5 matrix whose entries are all 0. Now you can also use ones, and it gives you the same thing, but all entries will be equal to 1. So let's create a matrix with 5 rows and 3 columns. Okay. Another useful command is uh, and it creates the identity matrix. Obviously, an identity matrix is a square matrix, so we don't have to specify number of rows and columns because they're the same. So we have to just mention the number of rows or columns. So in this case, it's going to give us a 4 by 4 identity matrix. There are some predefined numbers in Matlab, and you have to be aware of those numbers. And those numbers are predefined, and you cannot use them as the name of variables. So probably the most important one is pi, which is the pi number. The other one is infinity, which is obviously infinity. And we have NaN, which means not a number. When you have something that is not defined in mathematical terms, we use undefined basically, but in MATLAB it is not a number. For example, if you divide 1 by 0, you're going to get infinity because it is infinity. But if you have 0 by 0, you get not a number because it is basically undefined. Alright. The other important thing is the use of I or j for the imaginary number. You can use both I or j as the imaginary number, but also you can use these variables for any kind of predefined variable that you like. So if you want to use one of them as the imaginary number, you shouldn't be using that in your program as a regular variable. But in order not to get confused, it is better to use 1i as the imaginary number. This is a new definition that they actually introduced in the latest versions of MATLAB. So with that, you can define complex numbers. For example, let me define L, or let me choose another name. V equals to 1 plus 2 times 1i. Yes. So basically this is equal to 1 plus 2j in our notation. And it is a complex number. Now you can have vectors and matrices with complex numbers. I mean vectors and matrices whose entries are not simply real valued numbers, they are complex numbers. Let me create S equals to 1 plus 1i, 2 minus 5 times 1i, and let's say minus 6 minus 7 times 1i. Now this is a complex valued vector, obviously. Now if you want to transpose this matrix or vector, you have to use star apostrophe, as I mentioned earlier. This is a transpose. But if you use just apostrophe, it's going to give you the complex conjugate transpose of the original matrix, this one. So please remember that if you want to make the transpose of a matrix, you have to use dot apostrophe. If you want to make the complex conjugate transpose of a matrix, you have to use apostrophe. If you want to find just the conjugate of a matrix, you can use conjugate, and it gives you just the conjugate of that matrix. As you can see, this is a complex conjugate of this one. Okay. Now I'm going to talk about functions and plotting algebraic functions in MATLAB. But before that, we have to be able to evaluate the functions at the given points. Okay, suppose that we are going to plot a sinusoidal signal. Before plotting, we have to create two vectors for evaluating the sine or any other function at the given points. For example, we are going to create y equals to sine of x. Now we have to generate x as a vector. Now I'm going to generate x from 0 with the step size of, let's say, 0.01 to 2. And now we can define sine of x. Now we have two vectors. One is x, the other one is y. Now I'm going to show you the contents of these two vectors. X is this one. As you can see, it has 201 points. And y is this one. Also has 201 points. Now we are able to plot y versus x. So in order to do that, we have to first type the x value, the horizontal vector basically, and then the y vector, which is the vertical vector. And now by typing this and executing this command, we can actually see the sinusoidal signal. Now obviously this plot doesn't show the entire period of one sinusoidal signal. So in order to see the full period of a sinusoidal signal, we have to extend the vector x. So let me clean up the screen, and here let me change the value of x from 0 to 10 in this step size was 0.01 and 10. Now we have to re-evaluate the sine. Remember, you can't get the new vector y just by changing x. You have to redefine x or regenerate x and then regenerate sine based on the new vector x. So now you can plot x and y. Now you can see more than one period. So this is one period of the sinusoidal signal, and this is a portion of the second period of the sinusoidal signal. So this is how we can generate the plot. Now on the plot window we have a lot of tools, and you can use them in order to change the look of your plot. Now you can obviously zoom one portion of your plot or unzoom it. You can pan the plot. um, you can find the value of the points by using this cursor. So you can move it on the plot to see different values. You can insert different things like labels, title. So, okay, let me try again. Or you can insert labels X or Y. You can insert legends, color bar, line, or arrow, or text arrow, or double arrow, or text box. Simply you can write something, or rectangle, ellipse, and other kind of decorations like adding light, or so. For changing the color and stuff like that. So also you can make it three-dimensional. Obviously all of these are not working together appropriately, so you have to have a three-dimensional graph in order to be able to rotate it, or change the angle of the rotation and stuff like that. So basically you can do a lot of things with your figure. Okay. You can also use the plot command in order to plot more than one signal. For example, uh, let me create another signal, which is cosine of x, and I'm going to plot both sine, which was y, and cosine, which is z, on the same window. So the first pair will be the sine, and the second pair will be the cosine. You can see the blue line is the sine, the green line is the cosine. You can add grid, or you can add title, X label, and so forth here using the commands. Sometimes you need to show different graphs on different subplots or subwindows. For example, let me show sine and cosine that I have created on two different windows. First I have to close this, and now I'm going to create a subplot. Now because we're going to have two plots, so I'm going to create a matrix of subwindows. Now because we need only two subwindows, I'm going to create a 2 by 1 matrix. So the first entry shows the number of plots that we have on each column, and this is the number of columns. So The third one shows the plot number or the window number. So if I enter this, you see that it's going to create the first window here, or the first plot here. And now I can plot, let's say, the sign. So we have the sign here. Then I am executing this command on the same plot window, but that's going to be the second plot. As you can see, the second plot is created. Now I can plot the second graph, which is a cosine here, and that is the cosine. So by this method you can separate the plots, and you can have a kind of comparison between them without mixing them up. Okay. Now, sine and cosine are two functions that you can use. There are certainly more than two functions in Matlab. Now I'm going to talk about some of the basic ones. We have, for example, absolute value, ABS of a number. Let me choose 5, which is 5, or minus 5, which is 5. Now, if the number is a complex number, the ABS gives the magnitude of that complex number, which is 1 squared plus 6 squared square root. So we get the same thing basically. This function can work on numbers, vectors, or matrices. Basically, all functions work on matrices because, as I say, this is a matrix laboratory. Another function which is useful is tangent. So we can take tangent of a number. Remember, it has to be in radians. So the tangent of pi is 0. Now, that is a very good example. You can see that the result is not actually 0, but it's a very, very small number. It's 1.2 times 10 to the negative 16, which is very, very small. Remember, in Matlab, when we have a number which is close to the epsilon, epsilon is another predefined number in Matlab, which is this one. And when we have a number which is less than epsilon, or the absolute value of the number is less than epsilon, we can consider it as 0. So you can see the absolute value of this number is 1.2 times 10 to the negative 16, which is less than 2.2 times 10 to the negative 16. Therefore, we can consider this as 0. Other useful functions that exist in Matlab are, for example, real, which gives us the real part of a complex number. Let me introduce a complex number like minus 5 plus 7 times 1i. This is q. Now the real part of q is obviously minus 5. Now if you want to find the imaginary part, we can use the imaginary function imag. I talked about the absolute value. Sorry, it should be q. And also we can find the angle of Q, which is 2.19 radians. It's not degrees. And obviously the conjugate of Q is minus 5 minus 7j. Now the other functions that are useful is exponential. Exp is the exponential of a number which is equal to e to the power of 4. So that will be useful in uh, signal processing. And the other functions are, for example, arcsine, arccosine, and arctangent. So, for example, we have arcsine of, let's say, 1/2, which is pi over 6. And we have arccosine of any number. Let's say arccosine of 1/2 is pi over 3. And we have arctangent of any number. Let's say 1, which is pi over 4. So far I have talked about simple Matlab commands and how to use the command window and the Matlab software in general. If you want to have a simple calculation like adding two numbers or finding the sine and cosine of a number, you can just easily go ahead and use the command window in order to do your calculations. But if you need to do a lot of calculations and you need to write several sentences, several lines to execute, then typing them on the command window and running them one by one is not really wise, because it could take a lot of time, and if you make a mistake in one line, then you have to rerun all the sentences again from the beginning. So in order to avoid this difficulty, you can put all the lines and commands that you want to execute on MATLAB in a file which is called a MATLAB file. The extension of that file is M, so it's usually called M file. So in order to do that, you need a text editor. Fortunately, MATLAB has a very powerful text editor, and in that text editor you can type your program basically and run your program. So if you want to open the text editor and open a new file, you can go here and click on this icon, and now you have the text editor. So as you can see, it's a usual text editor, but this button here saves your program and run it on MATLAB, so you don't have to go back to the command window and type the name of your file to run the file. So what you can do here is basically what you can do on the command window. So for example, let me plot the sine and cosine that I plotted before. So I'm going to start with x from 0 with the step size of 0.01 to 10, and define y as sine of x and z as cosine of x. Now I can use the subplot command that I explained before to plot x. And to plot y and z. So we can turn on the grid. Now the program is ready. You have to save it first. So you can save it as a Matlab file. I'm going to call it test2, and it's going to be saved in your current directory, which is specified here. You can change the current directory whenever you want. Now the program is saved. You can run the program. Now you can see that we have two graphs, and on the second one the grid is on. So if we want to turn the grid on in the first one, you can just go ahead and add a line here and rerun the program again. When you push this button, Matlab is going to automatically save the program and run the program. Now you can see that both of the graphs have a grid. Okay, now you can write a very long Matlab file or very short. It's completely up to you, and you can create a separate file for different projects. Now another Matlab file that is very useful is called function. When you have a procedure, an algorithm for example, that has to be called several times in your program or in the other programs, you better put it in a separate file, which is called the function, and call it whenever you need that algorithm. Now in order to write a function file, you have to open a file like this, and the first word of that file should be function. As you can see, it turns into blue and means that you are defining a function file. Now the first parameters are the outputs of the function file, so you can actually consider the function file as a system with inputs and outputs. You may have several inputs and several outputs. So in this case, let me define two outputs, A and B, and then you have to come up with a name for your function file. Remember, the name of your function file should not have been used by other functions and commands in Matlab. For example, you can't call your function as sine or cosine. You have to come up with a completely different name. So I recommend you to avoid any general name that is used in mathematics, like cosine, tangent, arctangent, or similar things. You can put your own name, for example, if you like, or the other things. So in this case, let me call this test function 1, and suppose that we have two inputs. I'm going to call them x and y. Now here you have to write the algorithm that involves a, b, x, and y. So for example, we can define a as x squared plus y squared, and b as, let's say, x cubed minus y squared plus 2 times y. Basically, you don't need parentheses, so let me just remove the parentheses. Now this is a very simple function. Of course your function could be very complicated, but this is just an example. So next thing is saving the file. So we can go ahead and save the file. As you can notice, the name of the file should be exactly the same as the name of your function. This is very important. So because the file is function, MATLAB automatically understands that the name of the file should be the same as the name of the function. But if you change this name, you're not going to be able to successfully call that function. So let me save this function. Now the function is ready, and you can call the function wherever you want. Even you can call it from the command window. Let me do that. I'm going to create two variables, c equals to 7 and d equals to 5, for example, and I'm going to use them as the input to the function. And now I'm going to call the function. In order to do that, I have to define the output variables. So let me choose p and q as the output variables, and now I need the name of the function and the input variables. Now as you can see, the name of the input variables are different in the command window when I'm calling the function than the input variables in the function. This doesn't cause any problem because x and y here, the variables inside the function, are local variables, and c and d are global variables that are used in the command window. Therefore, they're not going to get mixed up. The same thing is true for p and q and a and b. But the most important thing is the order of the variables. So when you are calling the function, you have to pay attention to the order of the variables. In this case, c is corresponding to x, and d is corresponding to y, and p is corresponding to a, and q is corresponding to b. So this should be considered, and the order of the variables should be exactly followed. Now, even if you use the same names, x and y, you have to correctly follow the orders, because x and y in the command window here, the variables are going to be different than the x and y that you would define in the function, because as I said, x and y in the command window are global variables, and x and y in the function are local variables. So the only thing that you have to consider and follow is the order of the variables. Okay, now we are ready to execute the line or call the function, and by doing that we're going to get the results, and these two numbers are calculated based on the given formulas in the function. So 74 is the result of the first equation, which is corresponding to A, and 328 is the result of the second equation, which is corresponding to B. So this is a very simple function, so you can actually write a more complicated function and use this feature in Matlab. Okay, now I have explained whatever you need in Matlab to do your projects. There is another document that I'm gonna post it on the Blackboard. It's a very brief tutorial about Matlab. It has a little bit more information that than I have covered in this online course. So I recommend you to download that file and read it. It's going to help you a lot in doing your projects in Matlab. And please feel free to contact me or come to my office if you have any questions about the Matlab, or if you didn't understand the topic in Matlab, or even if you have problems with the files that the Matlab files that you are trying to write for the course projects. I will be more than happy to help you in those matters. Okay, so that's about it, and I wish you luck in doing your MATLAB projects, and I can conclude the online course. Thank you.